The aim of this video is to explain how the Excel sheet selection index can be used to calculate the regression coefficients, otherwise known as b-values, and to calculate the breeding value and to calculate its accuracy when there are multiple information sources. With this Excel sheet you can play around a bit to investigate the impact of multiple information sources on the accuracy of estimated breeding values. First, let's take a look at the Excel sheet. Here at the top, in the cells highlighted in orange, we can fill in the values for the heritability of the trait, the repeatability, and the C-square, which is the proportion of variance explained by the common environmental effects. If the repeatability and C-squared are not given, we can set them to a value of 0. Further down, in the cells highlighted in blue, we can fill in how many records we have for each type of information. Own records, records of the dam, the sire, records of full SIPs, records of half SIPs, and records of progeny. If we want to calculate the b-values and the accuracy for a new set of parameters, we can click on Run, and the calculated b-values will appear in the column called Index Weight, and the value for accuracy will appear in the purple cell. The column Value of Variance is not used in this course. The yellow cells labeled P matrix and G matrix are outside the scope of this course. The yellow cells with b-values and accuracy are the same as the values you see in the purple and in the pink cells. Let's consider a situation where we want to calculate the b-values and accuracy of the estimated breeding value for litter size for a sow with one own observation, an observation of the dam, 4 full SIPs and 20 half SIPs. Let's first fill in the heritability of 0.11, and we set the repeatability and C-squared to 0. Let's now fill in that the sow has only an own observation. If we click on Run, we obtain a b-value of 0.11 and the accuracy is 0.33. We expect to see an accuracy of 0.33 since 0.33 is the square root of the heritability, as we have seen before. Let's now say that we have a record of the dam of the sow for litter size, so we add that value to our sheet. We click on Run, and we see that the b-value for the own records decreases a little bit, and this happens because there is some overlap in the information of the sow and her dam, since they share 50% of their DNA. We can see that the accuracy increases from 0.33 to 0.36 because we have more information and therefore the estimated breeding value is more accurate. When we add 4 records of full SIPs, we see that the accuracy increases to 0.45. The 4 full sisters share 50% of the DNA with the sow of interest, and therefore the information on their litter size increases the accuracy of the estimated breeding value. Then, when we add 20 half SIPs, we see that the accuracy increases to 0.5, since the half sisters share 25% of the DNA with the sow of interest. So the accuracy of the estimated breeding value increases every time when we add additional information of relatives. In summary, the Excel sheet selection index can be used to calculate the accuracy of the estimated breeding values for any combination of information available. Furthermore, the b-values can be used to weigh the different information sources when estimating the breeding value of an animal.